90 degree. Hence, angle APB is equal to 180 degree minus sum of these two angles, minus angle PAB plus angle PBA. That means 180 degree minus 90 degree, which is 90 degree. So this angle APB is 90 degree. Therefore, angle APB is equal to 90 degree. Answer. Okay. This is the answer here. This is question number 4. Question number 4 we have completed. Now question number 5. In the figure given below, there is figure. The figure given below, if the area of the parallelogram ABCD is 108 square centimeter, then find the height of the parallelogram ABEF. Let me first draw for the parallelogram here. Question number 5. Now it says, in parallelogram okay, now this is a parallelogram here. Let me take this smaller one. Now this is the parallelogram and this is another parallelogram. It says AB, EF, sorry, this is E and this is F, and this is C and this is D. Okay, so this is, there are two parallelograms here. What are those parallelograms? Let me talk about this. How it says in the figure, in the given figure, in the figure below, or on the right hand side below, what is given to us on the figure below, the area, okay, the area of the parallelogram ABCD is equal to 108 square centimeter. Square centimeter. Okay. Then find the height of the parallelogram, and find the height of the parallelogram, this one, ABEF. This is parallelogram, and this is also a parallelogram. ABCD is a parallelogram we are given. We have to find out what is height of the parallelogram AB. Now again, these two are lying between two parallel lines, same parallel lines, because AB is parallel to DE, you can say. Solution let me take. So their areas will be same. The two parallelograms are lying between same parallel lines between AB and DE. Therefore, area of the parallelogram parallelogram ABCD will be equal to area of the parallelogram ABEF. So these two parallelograms are between the same parallels. So the area of two parallelograms will be same, but they are lying between same parallels, right? Why? Because the distance between them, these two parallels will be same. So we take base of this and base of this ever one, because the height between them is same. So height we have to just calculate. I'm just simply we are saying that okay, these two parallelograms are having the same height. Okay, so same height of base is same because base we have taken here AB. They have the AB as the base, ABCD, ABEF. So AB same base, height will also be same. They are lying. They are area of the parallelogram ABCD equal to. They are lying between. Okay, the two parallelograms are lying between same parallels AB and DE. And taking AB as the base, they have the same base. AB, we can take AB as the base. Okay, so AB is the base, same base, and therefore height will be same. Therefore area of parallelogram as we know is equal to base into height. We know this, base into height. Here base is same AB. Here base is the same. What is base here? Is there anything given? Okay, so only height we have to find out. If I just calculate that base is the same, sorry, okay, base into height. In the given figure, the area of the parallelogram ABCD is this 108 square centimeter, and find the height of the parallelogram ABEF. So height of them will be same. Okay, so let us take here what is the area of the parallelogram ABCD. They have the same height in this case. AB into H equal to 108 centimeter, and height is the same. So what is the height? We know that what is the height? Base is the same. In this case, base if I calculate in terms of height from the first one, and base is common, and height is also common here. So height can be taken as, let me take, because nothing, no base is given here. In the given figure, base into height is equal to 108 here. This is same 108 square centimeter. Okay, so therefore height is equal to height H equal to 108 upon. Well, what is the area of parallelogram? Base into height. Area of parallelogram is base into height. Therefore, this is base upon base. Now base is also not known. This is 108 upon B base. Right here. Because in this case, this situation I mean, no base is given. Because if I just take the same base is same, but height is not known to us. Height and base both are unknown. We can just take the 108 upon base, whatever the length of the base is given. Now base can be in different way. In this case, height can also be different. If base be changed, then 108 upon base B will give us the height of this. So this AB equal to EF or equal to CD. CD equal to EF also, because AB is equal to this. Base is the same, so height is same. Okay, so we can just say that AB in this case, so 108 upon B base, B here base. This is the height. Height is in unknown terms. It can be different values. This is how base is not given here. Find the height of the because in this figure nothing, no base is given. Only upon AB we can say. If base we have taken B, no problem. We can write here AB also. 108 upon AB, the length of AB. This is unit centimeters. This is the answer here. 108 upon base. Whatever base is given, base can be any unknown number. Okay. This is the answer here. Question number 5 we have completed. Let us talk about question number 6. Now question number 6. Let us talk about it. Question number 6 now. Question 6 says, in a cyclic quadrilateral ABCD, now cyclic quadrilateral is given to us. Suppose it is a cyclic quadrilateral ABCD. So in a cyclic quadrilateral ABCD, let me take in a okay, in a cyclic quadrilateral ABCD, in a cyclic quadrilateral ABCD, okay, in cyclic quadrilateral ABCD, angle A is 40 degrees, angle A is 40 degrees, okay, and angle B is 60 degree. This is 60 degree. 60 degree. 60 degree. Okay. Let us take now. What we have to find out then? What are the measures of the internal angles C and D? Angle C and angle D of ABCD. What are they? From here, okay, to find what is angle C equal to what, angle D is equal to what. Now in a cyclic quadrilateral we know that the sum of the opposite interior angles is 180 degree. So we should try to understand. This basic quality has been used here. In a cyclic quadrilateral, sum of opposite angles, or opposite angles are supplementary, we can say. Sum of opposite angles is 180 degree, or opposite angles are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. Supplement, their sum is 180 degree. Supplementary. Supplement sum of opposite angles is 180 degree. This 60 degree, this is 120 degree. This is 40 degree, this is 140 degree. Therefore, angle C is equal to 180 degree minus 40 degree. This is 140 degree. And angle D is equal to 180 degree minus 60 degree. That means 120 degree. These two are the answers. Angle C is 140 degree. Angle D is 120 degree. Answer. Because opposite angles in cyclic quadrilateral are supplementary. The sum is 180 degree. This quality of cyclic quadrilateral has been used here. Okay, let us take question number 7. Question number 7 here. Now question number 7. Question number 7 says, Let me check it. What does it say? It says in a trapezium PQRS. Okay, in a trapezium PQRS, and take another one trapezium. In a trapezium PQRS, how it has taken, let me take PQRS. In a trapezium PQRS, PQ is parallel to RS also. PQ is parallel to RS. Is so parallel, and PQ is equal to, sorry, this is 10 and RS is 20, so reverse let me take. I'm sorry, this is P, Q, and this is R and S. PQRS, okay, because this is 10 centimeter and this is 20 centimeter. RS is 20 centimeter. Okay, PQ is 10 centimeter, RS is 20 centimeter. What is the length of the line UB? UB. Okay, so UB is any UB. What is UB? Length of the line UB. What is UB? What is it? Now, which is parallel to both PQ and RS, alright, and between, and divides the distance between them in the ratio 2:3. Okay, the distance between them, it divides this distance, and then 2:3 ratio. Okay, divides distance between PQ and RS, divides the distance between them in the ratio 2:3 respectively. Now it says in a trapezium PQRS, PQ is parallel to RS and PQ is equal to 10 cm, RS is 20 cm. What is the length of the line UB, which is parallel to both this and this? Okay, it is given to us. Given a trapezium PQRS in which PQ is equal to 10 centimeter, RS is equal to 20 centimeter, UV is parallel to PQ, parallel to RS or SR. You can say like this. It means UB is parallel to RS also. This is given to us. And UB divides the length between the distance between PQ and RS in the ratio 2:3. This is the most important point. Okay, now if any line which is parallel in between the two parallel lines, now this PQ is parallel to RS undoubtedly, there is another parallel line which is UB. Now it divides the distance between these two in the ratio 2:3. Alright, this total distance is 5. If we divide 2 by 5, sum of the ratios 2 by 5 into. Now, if I take 2 above, then we take opposite side this 20 centimeter. This is 20 centimeter. SR is 20 centimeter. So 2 upon 5 into 20. Now we know that since this is solution. Now if I take, let me take angle trapezium like this. This is ABCD. Okay, now if there is a line here, let me take DE. Okay, and there is a line, in this case CDEF, let me take EF, and it divides in the ratio m:n. Over this length is n, and this is n. This EF line, this is parallel to both AB and CD, divides in the ratio m:n. Then length then length EF, length of EF, or length EF will be equal to M upon M plus N into, now if I take M above M, then opposite side this is AB plus N upon N plus N. Now this N is here, the opposite side is this CD into CD. Okay, so if I take ratio above the numerator N, then we take this side. If I take N, then take the side, then vice versa. In this way, is the length of this. But in this case, M is 2, N is 3. Therefore, since the length of the parallel side EF is given by this. If M is to N is ratio here. Therefore, here UB equal to, therefore UB is equal to 2 by 5. Why 2 by 5? Because 2 plus 3, 5 in the denominator, 2 in the numerator into 20 plus 3 by 5, 3 this by 5 into 10. This is the value. 5 for the 20, 4 to the 8 plus 5 to the 10, 3 to the 6. It is 14, so 14 centimeter is the length of line UB. Okay, this is the formula which we apply here. Now, if suppose this is the 1:1 ratio, means this is lying in the middle of the two sides. If this is 1.2, 1.2, then 1.2 can be taken common. 1.2 AB plus CD, or sum of the two parallel sides upon 2. 1.2 in that situation, 1.2, 1 plus 1 in the denominator and 1 in the numerator. If it is 1:1 ratio, that means the side is in between. That will be half into AB plus CD, length of the two parallel sides only, and divided by 2. That is the length in case if EF is parallel and it is in between the two. I mean, dividing equally in the same ratio, 1:1 ratio, or it is in the middle of these two parallel sides. Then length will be 1.2 into AB plus CD. That's the answer. This is 14 answer, 14 centimeters. This is question number 7 we have taken. Let's take now question number 8. What does question number 8 say? Let me check. Question number 8 now. Okay, now question number 8. So what does it say? Let me check. Its question says ABCD is a trapezium, okay, in which AD and BC are parallel. AD and BC here. AD and BC are parallel. Okay, so let me take a trapezium here. Like this. This is A, B, CD. So AD and BC are parallel. Okay, now it says if ABCD is a trapezium in which AD and BC are parallel, if the four sides AB, BC, CD and DA are 9 centimeter. Now this is AB is 9 centimeter. Okay, BC is, what is BC here? Where is BC? Okay, BC is 12 centimeter. CD is 15 centimeter. And DA, so we have taken reverse of this. Let me take ABCD from above. I'm sorry, this is ABCD. No, not like this. Which are parallel. Now it says ABCD are the parallel. ABCD is a trapezium in which AD AD and okay, so sides can be different one. Let me take the sides are different one. This is bigger and this is the smaller one. This is A, B, C, D. Now it's okay. Now AD is 20 centimeter. AB is 9 centimeter. This is 12 centimeter. No problem. This is 15 centimeter. Now it is these four sides are given to us. What does it say? If in a trapezium, ABCD is a trapezium in which AD and BC are parallel. AD and BC are parallel. Okay, right? Are parallel. If the four sides AB, BC, CD, AB, BC, CD, and DA are 9 centimeter, 9 centimeter, 12 centimeter, 15 centimeter, and 20 centimeter respectively, then find the magnitude of the sum of the squares of the two diagonals. Okay, magnitude of the two diagonals, squares of the magnitude of the sum of the squares of the two diagonals. We have to find out two diagonals BD and CA or AC. The two diagonals are there. We have to find out what is the sum of the squares of these two diagonals at a point. Okay, no problem at all. Let us find that what is this. Let me check anything other given. Then find the magnitude of the sum of these squares of the two diagonals. So we have to find out what is AC square plus BD square. Okay, that is the point here. So to find what is given to us, given here ABCD is a trapezium. A trapezium ABCD, we can say what is given, a trapezium ABCD, or ABCD is a trapezium in which AB is parallel to, sorry, AD is parallel to BC. What is given to us, and AB is equal to 9 centimeter, BC is equal to 12 centimeter, CD is equal to 15 centimeter, and DA is equal to 20 centimeter. All these four sides are given to us. No problem at all. Okay, so then what is given to us? Okay, then it says, I think then or respect, then find the magnitude of the sum of the squares of the two diagonals. So means sum of the squares we have to find out. Sum of the squares of the diagonals. BD square plus AC square. This we have to find out. No problem. So let us take this is 12 centimeter, this is 9 centimeter. What is this AC square? Let us take this AC square. Solution let me find. Now, what is area of a trapezium? We know that. What is area of a trapezium? Area of a trapezium is sum of the two parallel sides into height between them. Okay, length of the height. If I have to calculate, so what is the height of this or distance between two parallel sides, that we can find out. Let me just find out. Since area of a trapezium area of a trapezium equal to this way height, then we can calculate what is that height. We can find out that height. Okay, or if I just draw perpendicular here, and this is perpendicular, and this is 12 centimeter, or this is 12, this is 12. This distance and this distance is not known to us. If I take this as x, okay, so distance, that distance is calculated. in between. Okay, so that perpendicular distance we can calculate here. Okay, and if that height is known, then then we can calculate what is this. Right. All right. Since the area of a trapezium, we know that is equal to whatever. So now in this case, if I take this as x, and this distance is not known to us, it will be 12 means 8 minus x. This is 8 minus x. But this height h, this h will be same. From these two, if I just calculate that what is the area of this triangle, sorry, 8 minus x, if I have to calculate, this is h here, so h can be equated from these two, because this is 9 and this is 15. From these two right angle triangles, we can calculate what is h here. From that h, we can calculate that h is this. So let me find out what is the h here. But area, we can calculate area undoubtedly. H can also be calculated. Then this x can also be then easily. H can be calculated directly. Because area of a trapezium is, what is area of a trapezium? Distance between them, so h is not known. Okay, that is here. H area is not given to us. Not given. Okay, so let us take h. H will be then h square in this right triangle, in this right triangle. This is right angle triangle. This is right angle triangle. Okay, so what is that? Because this total 12. This is 8 remaining. 20 minus 12. This is x. Suppose this is 8 minus x. So h square in this case will be h square equal to 9 square minus x square. This is the first equation. In right angle triangle, this is right angle here. Let me take this B, E, and this is F. Okay, so in a right angle triangle, A, B, E, and this is height h. We have taken this height h. Distance between two parallels is same, so this is also h. Okay, so this h square equal to hypotenuse square. Hypotenuse is 9 centimeters square. 9 x square is the first equation. And in the right angle triangle, this one, which is CFD, we have from there also h square equal to